Okay, so like I said, I know for sure that you did probably problems like the first two. I'm not sure how much you did of what's below that. But just to review, when you multiply with like bases, so let's say you have x squared times x to the third, what do you do with your exponents? Do you remember? You add them. So this would be x to the fifth power. Okay. Now, if you divide with like exponents, what do you do with your exponents? You subtract them, okay? And so you would end up with x to the 2 minus 3, which is x to the negative 1. And if you have a variable to a negative power, if it is on the numerator, it comes down to the denominator. If it's in the denominator, it goes up to the numerator. So this ends up being 1 over x to the first power. Another way you can think of this one is you've got x times x on the top, and you have x times x times x on the bottom, because there's two x's on the top, two on the bottom. And these cancel. Okay, when everything cancels, it cancels to be 1, so you end up with 1 over x. That's another way you can look at it. Okay. All right. So that's just a little bit of review, just on the basics there. All right. So we look at these first two problems. Okay. Your coefficients you reduce, and then your exponents we do whatever we just talked about. Okay. If they're divided, you subtract. So we got 15 over 24. What goes into both 15 and 24? 3 does. Okay, so this reduces to 5 over 8. Okay, then we have to look at the x's. You have an x squared on top and an x on the bottom. What happens? You subtract, you get x to the first power, so it goes on top, right? And you have a y to the top and a y to the fourth on the bottom. Y to the third on the bottom. Okay, and then what happens to the z's? They cancel each other out, so that's my answer. Okay. All right, what goes into both 30 and 12? 6. Okay, so 6 goes into 35 times, and it goes into 12 2 times. All right, now, I end up with x to the 1 minus negative 2, right? What's 1 minus a negative 2? 3, right? So that ends up being x to the third power, and so where's that going to go? On the top. Okay, and then we have a y to the fifth on the top and a y on the bottom. Y to the fourth on the top. Just like that. Okay? Alright, so that's those kinds of problems. Now notice in both of these problems, everything is multiplied together. So I can just cancel all, till my heart's delight, okay? As long as, you are allowed to. But when things are added and subtracted, it's different. You can only cancel factors. You can't cancel terms, all right? And so, like in this first problem, number 3 here, I cannot cancel the 6 and the 3 because this 3 is hooked together with the x, okay? I can only cancel this x plus 3 with another x plus 3, okay? And so, you can, like I said, you can only cancel factors, not terms. So, what you do is when there's addition and subtraction signs, you need to try to factor to see if anything will cancel. And so in the numerator here, I can pull a 2 out, which leaves me with x plus 3 on the top, okay? Now when you pull the 2 out, you don't just throw it away. It tacks on, okay? Because these are, what you're doing is factoring. You're breaking it up into the things that multiply together to give you this, okay? So you can't just throw it away. So I end up with 2 times x plus 3 on the top, and then I have x plus 3 on the bottom. Now can I cancel anything? The x plus 3's. Okay, and so then I end up with 2 over 1, which is 2. Now, let's look at this in reverse, okay? If I had something like 2 over 6 and we reduce, right? The 1 goes on the top, okay? The 1 was in the bottom there, so you can just get rid of it. But if the 1 is in the numerator, you can't, okay? You've got to have a placeholder for that. All right, let's look at the next one. Can I do anything with the numerator? This goes back to what we did yesterday, the rules that we followed yesterday. Can I factor anything in the numerator? It's 2 terms. What do you check for if there's not a common factor? Difference of 2 squares. Is this the difference of 2 squares? Yes, it is. So this factors into x plus 1 times x minus 1. Okay. What about the denominator? Can I cancel anything out of there? a 4, not cancel, factor out. Factor out a 4, and that leaves me with x minus 1. So I factor the numerator, I factor the denominator. Now I look to see if there's anything that cancels. Can I cancel anything? The x minus 1 cancel. Okay, and so that leaves me with x plus 1 on the top and 4 on the bottom. Any questions on that? Is this coming back to you? Did y'all do this in Algebra 1? A little bit, maybe? Okay. All right, now, in this problem here, I've got a trinomial on the top and a binomial on the bottom. Okay, what am I going to do with that trinomial? Can I just cancel the 6 and the 4? No. I need to factor it, okay? So, I'm going to do my product and sum. What's my product going to be? 6, and my sum, 5. What multiplies together to give me 6 and adds together to give me 5? 2 and 3, right? Now, since this leading coefficient is a 1, I can go ahead and just do x plus 2 times x plus 3. Okay, what about the bottom? Can I do anything with it? It's the difference of two squares, so it factors into x plus 2, x minus 2. Okay, so now that I have it factored, what can I cancel? Anything? The x plus 2's. Okay, so then I'm left with x plus 3 over x minus 2. Can I do anything with that? Oh, no. Be careful. This is connected together. Okay, it can only be canceled with another x plus 3. Okay, I did that on purpose to see if anybody would bite. Okay, you cannot cancel that. You can only cancel things like that when they're multiplied together. These are added together, so it has to be canceled with another x plus 3. So at this point, we're done. Okay. All right. What about this guy? Can I do anything on the top? Factor out a 3, which leaves me with x plus 5. Okay. Now at the bottom, it's a trinomial, right? Coefficient of 1. So I'm going to do product and sum. What's my product? Negative 15. What's my sum? 2. What multiplies together to give me negative 15 and adds together to give me 2? 5 and negative 3. So this factors into x plus 5 and x minus 3. Anything cancel? The x plus 5's cancel. Okay. So I'm left with 3 over x minus 3. Can I do anything with that? No. Can't do anything with that. All right. What about this one? What can I do on the top? Factor out a 4. And that leaves me with x plus 5. Okay, what can I do on the bottom? Factor out a 3x. Okay, and that leaves me with x plus 5. Okay, does anything cancel? X plus 5 cancels. So I'm left with 4 over 3x. Okay, now, this one could be done a couple of ways, okay? What do we notice first on the top? We factor out a 3. Now, you know what? Sometimes I do it right above, especially when I know there's going to be more than one step involved. I can factor a 3 out, which leaves me with x minus 9, right? And what do I notice about the x minus 9? Difference of two squares. Okay, so I've got 3 times x plus 3 times x minus 3. That takes care of my top. What do I notice about the bottom? Can I do anything there? I could factor out a 3. Okay, now I'm going to show you how to do it this way, and then I'm going to show you something else here in just a minute. Okay, I can factor out a 3, which is going to give me x squared plus x minus 9. No, what is that supposed to be? 6. Okay. So then I have to do product and sum. Okay. My product is going to be negative 6, and my sum is going to be a positive 1. So what multiplies together to give me negative 6 and adds together to give me 1? Huh? 2 and 3. One's going to have to be negative. Which one's going to be negative? 2. Okay. So then this factors into, you can't lose that 3 that you factored out already. So 3 times x minus 2 times x plus 3. Okay, so can anything cancel? Okay, the x plus 3's cancel. Anything else? The 3's cancel. Okay, and so I'm left with x minus 3 over x minus 2. Can I do anything with that? No. Now, that first hour, we did not catch that you could factor the 3 out. Okay? So let me show you what happened in that case. All right? We had this 3x squared plus 3x minus 18. Okay? And we decided to do product and sum. Okay? We didn't think about factoring the 3 out. Okay? And that might happen to you. So I'm going to show you how to do this. So my product here would be negative 54, and my sum would be 3. What multiplies together to give me negative 54 and adds together to give me 3? 9 and 6, right? One of them's got to be negative. Which one? The 6, okay? So then we proceeded to do x squared plus 9x minus 6x minus 18. Then we group the first and the last together, okay? We pull a 3x out, which gives me x plus 3. Whoops, switch my pins. You pull a negative 6 out, which leaves me with x plus 3. There's an x plus 3 common to both, and a 3x minus 6 is what's left over, okay? What do I notice here in this second factor? It has a 3 common, okay? Because, you know, what I would have ended up with is 3 over x plus 3 times x minus 3, and then that would have been over x plus 3 times 3x minus 6. If when you factor and you look at one of your factors and it has something in common, you've got to pull it out, okay? All right? And so I really would have, if I had pulled it out, I would have gotten 3 times x minus 2 times x plus 3. And then I could have canceled the x plus 3's and the 3's, and I would have gotten the same answer, okay? But sometimes we think to pull out the common factor, and sometimes we don't. You just need to make sure you check when you're done to make sure your final answer is completely factored, okay? All right? Any questions? Isn't this fun? It's better than a proof? Yeah. All right. Got to put it all into perspective. Okay, so we've got a worksheet. I will pass that out.